if you could hit yours and record it too.
I am. Yep.
Okay, good. All right, gentlemen, welcome to SolderSmoke. Pete, what's the number?
252.
Much delayed. Today is the 18th of July, 2024. And yeah, so this makes it 252. It's a long delay, but very happy to see you guys here. And I will just say, for speaking for my part here, this is a momentous occasion because this is the first ever solder smoke from SolderSmoke Shack South, brought to you all by StarLink. So you guys may not know it or not, but my image and voice is shooting up to a low Earth orbit satellite, coming back down, and then going into Skype, and that's how we're doing this. I'm really delighted to see Pete and Dean online here this morning. This is kind of unusual. I'm using a clunky old Chromebook, and I can't get Audacity on it, so we can't do a whole lot of audio editing. We're definitely going to do the video. We might strip out the audio, but let me just say a few words about where I am. I am on the eastern tip of the island of Hispaniola, in the eastern tip of the Dominican Republic, about 90 miles from Puerto Rico. On the other side of those blinds right there is the Mona Passage, which is the body of water that separates the Dominican Republic from Puerto Rico. It's about 90 miles wide. I can see about 6 miles of it out to the horizon. Really spectacular view. I'll post some pictures of the view. I am on the air already, and I'm using the 1510 rig and an old 20-meter SBITX that I threw together, and an old, let's see, QAmp 20 amplifier. Puts out about 20 watts. My antennas are some really ugly prototype dipoles that I put together, fan dipoles. I've built them on the terrace of the house, which Dean saw a picture of it and said, "Man, your wife is being very patient." Okay, but I'm not going to press my luck, so I'm going to move the fan dipoles up to the roof of this thing, which will put them about, I think, about 70 feet off the ocean, with good views in all directions. So we're going to go for fan dipoles for 20, 15, and 10. But and later on, I could convert them using the same base that I'm going to have up there, convert maybe to a Moxon, or even if I get super ambitious, a hex beam. I'm kind of reluctant to do that at this point because I want to see how well it works out with just the simple dipoles. I got on the air on 20 yesterday with that little old rig that you see there, and the QAmp and a 20-meter dipole. And man, I was working all kinds of DX. I think without even trying, my DX CC count is now up at 23 or something like that. But who's counting, right? So here we are.
You are.
That's where I am. I'll try to post some pictures of SolderSmoke Shack South as we go along. But guys, this is sort of like in the prelude of the show. We want to get a lot of input from Pete and Dean, but I just think we need to say something because this is the first podcast that we've done since that infamous day of April 1st. We are big supporters of the old ham radio tradition of April 1st, and we did one this year that I thought was going to be just kind of innocent. We just made up this story about how the sticker that we put up at the corner of Haight-Ashbury was mysteriously removed because Alpha Alpha 7 Echo Echo, he went by and took a look at it, and he reported that it was gone. So this provided the basis for the completely bogus story that the San Francisco authorities had taken it down and were seeking to prosecute us. Well, me specifically, because the website on the sticker could be traced to me. So at this point, I'm going to go off camera for a second, and then I'm going to return.
Oh.
And I'd like to just say at this point that I've been placed in the Federal Witness Protection Program, and they have located me at an undisclosed location in the Western Hemisphere. The thing is, we got a lot of responses to the SolderSmoke story. One of them was really surprising. Most of them, a lot of guys got it. They just laughed. a lot of guys were outraged by it and said, that's outrageous that the city of San Francisco is doing that to you. One guy wrote back and said, you guys got what you deserve. I hope this is a life lesson for you. Stop defiling the streets of San Francisco. That beautiful city has a right to stand up against vandals. He called us vandals for doing that, and encouraged the prosecution of all of us, but me specifically. So this brings you to the point of the sunglasses. I have decided to testify against the unindicted co-conspirators in this case, both of whom I would point out, these two guys right here have roots in the state of California. I do not, right? So I've been asked to testify, and I will, this is all bogus, of course, but I will testify under the Federal Witness Protection Program against Dean Souleles and Pete Giuliano, native Californians, both, well, Californians of some sort, both. And I'm going to try to get off the case. So let me return now. Hold on.
I don't know. Turning state's evidence. I never
There you
thought
go.
it.
All right. So now we're back. But
Or
listen,
your coax get shorted.
man, but we were surprised about this guy who came back and said, you guys deserve it. It reminded me a lot of the old meme of like, get off my lawn. I have a picture of that. Hey, and also he reminded me of like the library cop on Seinfeld. If you guys remember that episode, the library cop comes back and charges Jerry with withdrawing a book from the New York City Public Library 15 or 20 years earlier, and he has a huge fine pending. And Seinfeld is like baffled by the enthusiasm of the library cop. But look, I just want to say something. A lot of guys feel bad about falling for our April 1st scams, and every year we get a few guys who fall for it. I want to point out this year I also fell for one. And so I am part of the April Fool's Club, and none of you guys should feel bad about being victims yourself. Mine was about WU2D. Mike WU2D put together this fantastic video, and it was the premise of it was that Timmy, WA1HLR, the Timtron, as they say, had suddenly appeared on single sideband after a lifelong passion for AM and condemning the users of single sideband, which he always refers to as slop bucket or single slop bucket. And anyway, Mike had this long conversation supposedly with Timmy, and Timmy was using some sort of Yaesu ICOM or Kenwood rig, and he was on SSB, and he was talking about how SSB is not really that bad. And I fell for it completely. I guess by the end of the day, it was sort of close to the end of the day when I saw it. I guess I had mentally checked out from April 1st. But anyway, so don't feel bad, guys. I fell victim. Did either of you guys fall victim to anything? These guys, they're smarter. They're a lot smarter than I am, both of them.
No, we just don't look.
Our friends are not as cruel.
All right. Dean, we're going to turn it over to you because you've got a lot of stuff, man. You've been working on a lot of things on the bench. So over to you, Dean.
Yeah, so I've been working on my homebrew version of Farhan's sBITX. And last time we spoke, I had to go back and look because I had just finished kind of a 5-watt power amplifier, a low-pass filter board, and a homebrew microphone. And so I was able to get on the air, make a few contacts, but as usual, things weren't working the way I wanted, and I still had the power amplifier to build. I wanted to build that 20-watt power amplifier. So I built my own 20-watt power amplifier out of two RD15 transistors. And this led me into kind of the black hole of how do you properly set the bias, and how do you think about third-order intermodulation products? And I asked some questions on the BITX forum, and I got responses that were pretty generic, like just look at the IMD, or your bias is too high, right? Well, it's like, because I think in Skelton's book, he biases the RD16s at 500 milliamp. And Allison said, you're wasting power to do that. She thinks maybe he was trying to get IMD products down. But I just asked 3, 4, 5 times, all right, how should I think about setting the bias on these transistors? And what am I looking for in intermodulation products? And by the way, the if you measure intermod, at what power do you measure it? Are you measuring it at peak power? You're measuring it at, and nobody would or could answer those questions. So I finally found a nice Motorola engineering worksheet that described the process. And, they said you want to get about 60% of peak envelope power, and then they give you a formula for looking at so I kind of figured that out, and I finally got the amp bias. The great thing about this amp is it is flat from DC to 30 megahertz, and I can get 20 watts out on CW key down all across the band, and that was great. But then I found out that my driver stage couldn't drive it flat across the band, and I had to spend a lot of time going back and rebuilding the driver stage, and that was an issue of 2N3904s are probably underpowered and they can't take enough current. So I ended up getting some old 2N3866s that I had, and I just replaced the first two stages with 2N3866s, played around a little bit with the emitter resistors, and I got that stage working. So now the sBITX was transmitting at 20 watts out on all bands, except I ran into the next problem, which is as soon as I started transmitting on, anything below 20 meters, all the low pass filter transmit relays started chattering away. It sounded like machine guns going off on my board. Like, all right, don't want to do that. Stop. Take your hands away from the microphone. Take a look. So Farhan's response to that was, oh, well, the GPIO lines sometimes pick up RF, so put caps on the GPIO line. So I did that, and that mostly cleared it up, but not completely. And then there's other relays on the board. There's a relay that basically controls the entire transition from transmit to receive and back, and that relay was going off randomly. And Pete helped me figure that one out, and that got us to this what did you call it, Pete? Subthreshold conduction.
Yes.
Right. So
Yes.
so the idea that a transistor conducts when it's not supposed to, and
Leaky.
and the term comes from FETs, but it applies equally well to BJTs. And Pete thought that I was, one, not putting enough dropping resisting in the line. So I increased the dropping resistor from 220 ohms to 2.2 k ohms. And he suggested I go to a tip type transistor, which I didn't have any, a tip 31, I think you recommended. But I just replaced the 2N3904. And the combination of those two things cleared it up. So no more random transmit issues at all, and subthreshold conduction. And that created a lot of controversy in our makers group weekly chat with one of our RF engineers trying to tell me, well, that doesn't apply to bipolar transition. This guy does this all the time. And I said, well, it's okay. The concept is the transistor is conducting when it's not supposed to.
I have had nightmares now about subthreshold conduction.
You definitely should have nightmares about it. So
it's a scary thought. Thanks, Pete.
So moving on. Shortly after I got that done, I got an email from our friend KA4KXX down in Florida, Walter, and we had a really nice scheduled QSO. He was on a homebrew 10 watt 20 meter BITX, and I was on the homebrew sBITX, and we had about a 20-minute QSO from Virginia to Florida. Good audio reports. Always a pleasure to work. Walter's a hoot to talk to. A lot of fun, and that was really good.
Walter is fantastic because, like the three of us, he is a believer in kind of alfresco construction, and a lot of his rigs are on a pine board, and he unlike us, he keeps them on the pine board. He doesn't box them up. They're all laid out there with all the guts exposed, and they're things of beauty. So I always admire Walter's rigs for that, and for many other reasons too.
Well, on my blog, I've got a picture of the day of my rig and his rig on the day we had the QSO. So that's on there. And yeah, he says he's got like a little plexiglass cover when he wants to go out to like parks on. He's doing more parks on the air. He wants me to get on and do parks on the air. So I can't imagine taking my piece of plywood out to parks on the air, wires flying all over the place.
People think you're nuts, Dean. When if you bring out something like that, they'll just be calling the ambulance at that point.
All right, so now let me get to my current tale of woe. All right, so after getting all that done, there were two little modules left in this build that had to be put together. One is a real-time clock, and the real-time clock is basically a little battery backup clock that you plug into the Raspberry Pi that keeps the time when the Raspberry Pi is turned off, because it doesn't have any kind of a clock. And if you're gonna take your sBITX out to the field and do FT8, then you got to have a synchronized clock. So I thought, all right, I hadn't needed up to now. I don't plan to do FT8, but I don't like the fact that the time on the screen is wrong if it can't connect to the internet. And plus, when you make log files, electronic log files, you want the proper date and time. So that works on the I2C bus. So that's one module that needed to be built. And then the second module is an SWR and power meter. And that consists of a Stockton bridge directional coupler, which is a pretty standard circuit. And then for the forward and reflected power, it's sampled by an AT Tiny, a little 8-pin microprocessor that's, kind of an Arduino equivalent. You can program it with the Arduino. And it's a very simple sketch on the AT Tiny. It literally responds to an I2C call, analog reads those 2 pins and sends the data back to the Raspberry Pi where the main action takes place. When Farhan built the sBITX, he ran into a problem with the I2C bus with the audio codec he chose. And he found that he couldn't run the SI5351 and the audio codec on the same bus because they interfered with each other. So he implemented a software version of an I2C bus that he runs on 2 additional pins on the Raspberry Pi. So you have the built-in hardware I2C, and then you have the software I2C. He put the real-time clock, the SI5351, and the AT Tiny on the software bus. So now we're talking, he calls it the BitBang I2C bus. So now we're on the BitBang I2C bus. And I get everything hooked up, and I hit the transmit key, and I'm getting 0 power, 1.0 SWR, like nothing. So I find the place in the code where he's reading those values, and I print out just what the Pi thinks are the forward reflected power, and they're coming up both up -1. I'm like, oh, what the heck is going on here? Did I do something wrong with the directional coupler? Did I do something wrong at the? So I tested the directional coupler separately. I have 1.5 volts on the forward pad, which is you're rectifying the RF, and you're basically turning it into a voltage so you can measure it. And the AT Tiny analog to digital converter runs at 3.3 volts, so that's within the 0 to 3.3 volts. So that's a perfectly good value. And so my coupler's working fine, but the AT Tiny is responding on the I2C BitBang bus because it's sending back data, or at least the Pi thinks it's sending back data, but the Pi is only seeing -1 on both forward and reflected power. I am stuck at this point because the AT Tiny circuit is dead simple. There's 4 lines that run I2C, power and ground, and a clock and data, right? And that's it.
So you guys, I got to stop it right now, because you guys know what I'm going to say at this point, right?
I do.
And I think our listeners know what I'm going to say. But this doesn't happen with my LC oscillators. But I'm going to, Dean, carry on. I just said it. I felt like I had to say it. I had to get it out there.
Bill, your LC oscillators amplify and your amplifiers oscillate. So let's not get too proud. Anyway, I've been back and forth with Farhan on this, and I get I kind of had that problem, but I don't have any solution at the moment. And the puzzling thing is the real-time clock, which is a module that you buy. It's a $4 module you can get off of Amazon, and the SI 5351 and the AT Tiny are all on the BitBang bus. So I know the BitBang bus is working okay, and I know the Tiny is working okay, but the connection between them, something is happening that I'm only getting negative ones, like all ones on the day that comes over. And so I even built a tiny little board with just the AT Tiny on it that plugs directly into the sBITX hat that Farhan made, thinking maybe my wires were too long or something like that, but I don't know. So I'm stuck. Anyway, that's my tale of woe at the moment. What ought to be the simplest little section of the transceiver is hanging me up now.
If anybody out there has a good suggestion for Dean and his current tale of woe, please send it to him. Dean, Pete, you got any ideas?
Hey, Dean, I was just going to ask a question. Are you forever locked to a Raspberry Pi, or can you put another single board computer running Linux to run the sBITX?
I don't see any reason why you couldn't. I mean, it would be a port, right? You got to take Farhan's code and port it to the new Linux, but you could run a different Linux.
Well, the reason I ask is there's a really neat sleeper single board computer that has a built-in real-time clock. That's the Atomic Pi.
Oh yeah.
$49. $49 for that jewel. And if you could port over everything, you get the real-time clock, and it's a little different architecture than the Raspberry Pi, but I have successfully used that in place of the Raspberry Pi on some of the stuff that I've built. So that might be something to look at. It's a lot cheaper too, at $49 for that unit. It's actually got an Intel processor on it with a big heat sink. So you might think about looking at that, seeing that a solution may be a different single board computer.
The trick is the audio codec is pretty well tied to the Pi, so you have to make sure you can convert that and get the right drivers. But if it's Linux, I'm sure you can do it.
Yeah.
One of the guys on the BitX forum has already taken Farhan's 32-bit code and ported it to the 64-bit current operating system. And actually, that's the build I'm running now, and that's working really well.
I foresee more tales of woe if Dean goes down this path.
Well, just to close it off, I have taken your advice, Bill, and I went to the craft store and I bought some wooden boxes to package my high-end digital SDR radio in, and I got some copper tape for grounding it, and so I've got, but I'm reluctant to start packaging it up when I still have a circuit that's not working.
Of course, as soon as you package up, even if it is working,
nothing's going to work.
Thank you very much, Dean. Thank you for sharing that tale of woe with us. Pete, we've been waiting to hear from you, and it's really cool that you got the CB symbol behind you there. I think the construction battalion of the U.S. Navy is right there.
Yeah,
excellent.
Can do.
So, Pete, you go ahead.
I even own the movie, The Fighting Seabees. I watch it
occasionally. There you go.
John Wayne.
Good stuff, John Wayne. Yeah. Hey, I have on the list here 2 things that you were going to talk about, but you could talk about whatever you want, of course. But one thing I had was you, Pete, were the one who exposed us and alerted us to the wisdom of RF Man on YouTube. And if anybody out there is looking for somebody who really does a great job in explaining how amplifiers and circuits are designed and put into operation, just search for RF Man on YouTube. I'm going to put the link up on the blog. And as Pete put it, he is the man. I mean, it's amazing. He does a lot of work on CB stuff, but don't let that put you off, because a lot of it is relevant to ham radio, and he's got a great style and a really wonderful, I'd use the word knack for explaining things clearly. So that's good. But then, Pete, I think you were also going to tell us about your refurb and rejuvenation of the beloved Drake twins.
Yes. Before we move to that, I wanted to go back to, I don't know what's happening, but stuff shows up on my phone. And for some unknown reason, the RF Man showed up on my phone. I have no explanation why, but that AI must be working in the background there somewhere. So I looked at it and said, hey, this is pretty cool. Probably Dean and Bill would be interested. I mean, it's
And
not something I went
you were
looking for.
talking to me, and then RF Man got into your phone, and there you are.
Yeah.
Soon you'll be building CB amplifiers for 11 meters. Watch
Hey,
out.
that is a big business. You know, those CB amplifiers start out at 2.5 kilowatts. I mean, and it's by number of pills. It's a 4-pill or 6-pill or 8-pill, and it's a 16-pill. And the guy shows you the watt meters, 2.5 kilowatts, and it's this box with big fans.
Probably about 2.5 kilobucks too.
Yeah, big number. So anyway, I have this terrible affliction. I keep looking at eBay at all these old boat anchors, and I spotted a T4XC transmitter, Drake T4XC, that cosmetically looked pretty good. And the thing is, it didn't have a case cover. Had the bottom part of it, but did not have the case cover. And so the guy was asking pretty low prices and says, make an offer. So I made him an offer. I said, $120. He said, good, yours. So I got the T4XC at home. And it amazes me because I think a lot of these things are being put up for sale because people just don't understand what it takes to make them work. And I found out by the time I got to the C line, they were more of a hybrid rig than just a pure tube rig. Like in the early Drake or R4 and T4, they are mostly tubes. And matter of fact, the very first R4 had 13 tubes in it because they had no solid state devices. Then they built an 11 tube version. The VFO was then turned into solid state. So I got this thing and it didn't work on transmit. And when I hit the mic button or hit the key button, I didn't hear a relay click. And I says, well, it's not being turned on. And I noticed the bias worked, so that was a good sign. It didn't go pin the needle. I mean, you could adjust the bias, so that gave me a pretty good idea that probably the tubes in the final were okay. So believe it or not, in the days of old, there were actually vacuum tubes made for controls of relays, and one of those is a 6EV7. It's a tube specifically designed to control a relay in the plate circuit, like just you were talking about your relay with a transistor. This is the same principle, only the relay is in the plate circuit. So there were two tubes that support the operation. One was a 6EV7, and the other was a half of a 12AX7 that has another purpose, but this was the initial driver that drove the relay tube. So I said, So I had a 6EV7 from a former Drake refurbishment, and that seemed to work intermittently. And so then I pulled out the tube tester and checked the 12AX7, and I found out that half of the 12AX7 wasn't working. So I put a 12AX7 in there, clicked the button, the relays clicked. So power it up, and it works. So I mean, for about a $10 tube, this thing was put on eBay because someone just never went through the analysis of looking at the block diagram and then doing a fault tree analysis, said, why won't this thing work? So, I mean, there are a lot of bargains out there that you can find. So I have a transmitter without a case cover, and I'm pretty certain that the covers were universal. So if you have an R4 or R4, R4A, R4B, or the R4C, or even the transmitter covers, they're all interchangeable. So if I found another junker type radio with a case cover, now I got a pretty good transmitter with a case cover. So once you get that, you say, gee, now I got the transmitter working. What can I do for a receiver? So I found a similar case with an R4C receiver that was very low price. Typically the R4Cs, sometimes they get $1,000 for them or more. And the reason is Bob Sherwood, NC0B, kind of started out by taking the R4C and converting it to a super duper receiver. At one time, this was at the top of the pile in terms of receivers that you could buy. So when he publishes the list, the R4C is still in the list, but is not at the top. It's now a Yaesu device. But he came up with a concept of a roofing filter. It was later built into the transceivers and transmitters and receivers, a roofing filter. And he really created a tremendous thing. And he did a whole bunch of things. Like he says, first off, get rid of the audio stage. It's got a crappy audio stage in it. So he had a little business going, building all these modules. So the R4C was very highly prized. As a matter of fact, it's unique from the other Drake receivers in that it has plug-in filters. So you can put it in a 1500 hertz, a 250 hertz, or 500 hertz CW filter in the back, and it's got 15 crystal positions aside from the normal handband. So you can crank that thing up, with the exception of a couple of ranges where the VFO operates. You essentially have an all-band receiver from DC to 30 megahertz or beyond if you put some transverters on, and with the exception of just the range where the VFO operates. So I got this thing, and the first thing I did is kind of checked all the tubes, and it has, believe it or not, at this stage of the game, the R4C is very much a hybrid receiver. It only has 6 tubes, and the first R4 had 13 tubes, so now you're down to 6 tubes. So most of the stuff has been switched over to solid state circuitry, and most of the transistors that are used in there are pretty common stuff. I mean, it's not like some of these have dual gate MOSFETs that you can't buy. You've never been able to replace. So these were all standard devices. So after I replaced the 6 tubes, receiver works. So I've got them cabled up, and I've got it working back and forth. And so it's really nice to see it can be operated independently. The transceiver mode can be operated from the transmitter PTO or from the receiver PTO, or separately. So I got on the air, the first contact, and 40 meters. And a local guy here, I think he's down in the San Diego area. And I said, yeah, I'm testing out a new radio here. It says Drake C-Line. So he comes back to me and he says, well, he says, your audio is very clear. He says, it's just in the mid-range. He says, but you don't have a lot of highs and a lot of lows. He says, so you need to go into the menu.
Hey, but Pete, you don't understand something. Dean and I paid that guy to tell that to you.
he said, go into the menu, call up the screen, adjust the sliders.
Hey man, you're 30 hertz off, Pete. You're 30 hertz off.
Yeah, lows and highs. He said, and it'll be full range. He says, open that up. He said, you want about 2.8 kilohertz. So I said,
oh man,
this is a 1970s radio.
Well,
now you can put Julius's box there to be 2 IHY and do all that, externally. I said, but it does not have that. He said, well, then you're just going to have to live with it. I said,
yeah,
right.
Probably, yeah, we could do that.
Yeah.
It worked for 40 years before, so it'll probably be okay now.
But wait a minute. We're bringing this into the homebrew world. I got a friend, JJ, W9JES. He did the 64-bit conversion of the software BITX. Remember, software BITX, it has a Raspberry Pi SDR. He has added all of those nifty audio manipulation controls to the sBITX. I have it now. I can make my audio sound as bad as everybody on an IC7300.
Just remember, guys, menus are for restaurants. All right.
I mean, this guy was serious. So what I think there's an appreciation that our hobby has taken a turn now. It's audio files, the audio file stage is at 2.8. And I hear guys saying, oh, it really sounds good at 6 kilohertz. Yeah.
Everybody else is receiving it at 2.7, but it sounds great at 6. Yeah. Hey, but listen, I want to make a couple comments about what Pete said about the relays and the relay drivers. First of all, I want to say, Pete, this is the kind of radio refurb or radio rejuvenation story that I like to hear. Now, on another podcast, they had one that was called Radio Rejuvenation, but I was kind of disappointed, mildly disappointed. I usually like that podcast a lot, but I was mildly disappointed because their version of radio rejuvenation meant taking old rigs like the Drake Twins and the Collins rigs and just stuffing a whole bunch of digital circuitry in there so that they would look sort of like the old Drake or Collins rig, but they would be really SDR rigs. And I kind of just, well, of course, I rejected that. But the other thing you said about the relay drivers and your ability to determine which half of the tube was bad and the use of the tube tester, that's really good troubleshooting. You know, I had problems with relay drivers with two separate rigs. First, with the HT37, when I first got back on the air, I felt like Rip Van Winkle because I still had my Drake 2B in the HT37. It was 1993 in the Dominican Republic. And sometimes the TR relay would just not click over. In other words, I'd reach up in the front panel, I'd go from receive to transmit, and boom, the relay wouldn't click. And I couldn't figure out what was wrong. Why wasn't it doing this? Why wasn't it doing this? The problem, it turned out, was the line voltage. The line voltage at that time in Santo Domingo was pretty variable. So if they had it running it properly at 115 or 110 volts, it was no problem. But if it dropped down to 90 volts, the relay wouldn't click over. And I discovered the solution to this was when I went on the air, I just fired up the generator in my backyard and I got 115 volts and the problem disappeared. I figured that was great. The second problem I had was with the Heathkit HW101, which I never really resolved. That always had a problem with the TR relay, especially with the CW circuitry where you'd set the time constant. And, you know, after you release the key, like a second or half a second would pass before it would switch over. And sometimes it would just go really, really long. I suspect it might be the tube that Heathkit had in there.
C2, yeah.
And I just didn't know that until you just said it. So if I ever do go back and start working on the HW101 again, I'll check that bit. But thanks for the radio rejuvenation, for the real radio rejuvenation, Pete.
You know, just an interesting point about the Heathkits. They put tubes in there with the name Elmenco, EL capital MENCO, Elmenco. One of the things that people found out was they were 5-volt filament tubes that they were using at 6.3 volts. And over a period of time, those tubes would go bad. And it's just that they got a hell of a deal on them, but people never knew. They thought they were 6AU6, but it was really a 5AU6 that was
They went from Elmenco to El Dedo real quick.
yeah. So that's the thing. But by the way, you can also see some interesting. You should mention that some interesting refinements in the C versus the prior models. They actually have two pots on the back of the back panel. They actually have a time constant for CW and a time constant for single sideband. So you can adjust them how long you hold in after you key up. So you can set it variably longer for CW because you don't want to keep, just chopping that relay. And on sideband, it's a little different because we're talking there. The other thing is just a final note here, and I'll turn it over to you, Bill, is the S meter. They had a pot. They had a pot on the back of the back panel to adjust the zero and the S meter. I could get the S meter to move, but it wouldn't zero. It wouldn't go to the 0 point. So I said, well, when that happens, a couple of things, because I've seen this before, some of the resistors will drift. They actually use a bridge mechanism for the S meter to set it. So there's several tubes and several resistors in there that set the bridge so that you can set it on 0. So I said, geez, I hate to think go in there and change the resistors because I had to do that once on a National NCX3. So then I pulled the schematic up and I discovered something. It was really fascinating. Drake had 2 trimmers in series that zero it. So you had the back panel trimmer and you had one inside the radio. So they must have realized that over a period of time, as the resistors age and the tubes age, you weren't going to be able to zero it. So all you needed to do was go in the inside of the radio and adjust the pot in the radio to change that value. There was a 1K pot and a 2K pot. The one on the back panel was a 2K. So just tweaking the 1K pot changed the value so that you could then zero it in the back. So I mean, that's not anywhere in the documentation, not anywhere that you would jump out at you say, oh yeah, you have this problem, do this. But I mean, if you just look at it, you say, oh, I know why they put 2 resistors in there.
This just proves when you know stuff, you can
You
do
could do
stuff.
stuff. Yes. Yeah. So anyway, it's been fun to solve these things. Now I imagine some guy that didn't spend any time looking at the schematics or has had a little experience reworking some of these old boat anchors just says that doesn't work. Now the relay doesn't click over. Sell that thing. Get rid of it.
Put it on eBay. Sell it to Pete Giuliano.
Yeah. Yeah. There you go. There you go. So anyway, what little time I have, it's the kind of thing where you can spend 20 minutes to half an hour that my schedule may have to work on something, but it's not enough time to build something. So anyway, it's been
It's
a lot of fun.
but it's very satisfying fix there, Pete. Really good. Hey, I just want to. There's a few things I have on the list, and these are kind of a lot of them are kind of holdovers because it's been so long since we did a podcast. We've got a lot of excuses. I moved temporarily to a different country. Pete's got a lot of personal responsibilities. Dean's got a lot of stuff going on. Congratulations, Dean, by the way, new granddaughter. They're very good. Um, Listen, one thing I'm going through the old list. I have something here called MXM News. This was a rig that I picked up at Winterfest. It's called the MXM, and it's a little transceiver for 40 meters CW. And I was talking about this on the SolderSmoke blog, and all kinds of information came in. I got new docs and ads from WD5L. All of them are on the blog. I got some 7030 crystals because the original frequency was sort of taken over by digital stuff. I heard from a really wonderful, real homebrew hero, Chuck Adams, and he came in and sent me some mods that he had worked on back when the MXM was new. First of all, we found out what MXM means. It's a form of Roman numerals for 1990. That's what MXM means, right? So that's the year that this thing came out. Joe DL6ID gave me some questions about the VFO and where the VFO is derived. I'm not sure whether it's from this is in the mod that Chuck Adams did or whether in the original. I don't remember. But in this circuit, the VFO is coming from the receiver. So the transmit VFO is from the receiver. And finally, the guy who built this thing at MXM Industries was Bruce Williams. And the question was he an early Swan designer? There are some indications that he was. There's some indications that, well, maybe not. We're not sure. What do you think, Pete? You know about Swan.
I don't know.
You don't know him. All right. Okay, so thanks for all the MXM news. Then I ran into, I have my own tales of woe that I'm going to share with the group. And they revolve around this rig, the 1510 rig here. And what I started to discover was that my 1510 rig just sounded weird. It sounded bad on receive. And I started wondering why. And I focused on all the wrong reasons, which took me down many different tales of woe, paths of tales of woe that turned out to be not the cause of the problem. But first, I'll tell you about what I found out. There is a problem with running the IF, the crystal filter, at very, well, higher frequencies than normal. We're used to running crystal filters at 10 megahertz, 5 megahertz, down in that range. On this one, because I'm trying to do band imaging, the crystal filter is at 25 megahertz, which is the highest crystal filter I've ever built. And because we have good tools now where we can do band sweeps across the filter, I began to realize that the curve, the pass band, the top portion of the curve of the pass band on the 25 megahertz filters was curved. It would start out low, peak, and then go down. Almost all the other filters that we built, the pass band is flat. I think flat is better. Curved is not so good. And as I looked into this, I discovered that this might be an inherent quality of the crystals that we're using, the Q of the crystals that we're using, and how the Q decreases as you increase frequency. So I kind of pulled my hair out this a long time around, but then I also noticed that other people had built crystals filters at this high frequency also. For example, Farhan's Minima, the Minima had a filter built at 20 megahertz, not quite 25, but 20 is getting up there also, and it too had a curved pass band. So the question I had is the curved pass band, is that a showstopper, or is that just something you just have to sort of accept and say, okay, look, that's the problem that comes along with building a filter at 25 megahertz, but you could still build a very decent sounding receiver. And I started consulting with different people on this. I talked to Allison. Allison shared a lot of really good KB1 GMX. Allison shared a lot of good wisdom, as she always does, on filters at higher frequencies. She talked about the importance of physical layout. And it is indeed more difficult to get things to work right at higher frequencies. But I pointed out, I said, this is another case where we should not let, to quote Voltaire, we should not let the perfect be the enemy of the good. If I could make a good receiver and a good transmitter with a crystal filter that has a pass band that's a bit curved, okay, so it's a bit curved. It still works okay. So that's the one I went with. One question I'll ask to the group: am I the only one in the world running a homebrew band imaging transceiver that covers 15 and 10 with a 25 megahertz IF? Has anyone else done this? I'd be astonished to find out that I'm the only one, but I haven't seen anything in the ham radio literature that points to a similar rig. It's actually quite useful at this point in the sunspot cycle to have a dual bander that'll cover 10 and 15. Now, the reason you would pick a 25 megahertz IF is that you run the VFO down around 3 megahertz, right? And so the addition product coming out of the mixer is 25 plus 3, you're on 10 meters. The subtraction product that comes out of the mixer, 25 minus 3, you're getting close to 15 meters, right? So it's a very practical and easy way to do a dual bander. And I just wonder, is there anybody else out there aware of anybody else doing this?
Well, what did Nick the Vic use? He built a 1015. M0
yeah, but
NTV.
His IF was lower.
Oh.
And he was using, Pete, he was using your SI 5351. So he could pick different frequencies for the VFO, but me, I'm using just an LC VFO, and I can't move it that far. I can move it a little bit, but I can't move it as far as Nick the Vic did.
And he didn't use broadband transformers. He used like LC filters on each band. So he's got a very different one. But Bill, when you're talking about these new tools, it reminded me of when I got my first really high-end digital camera, and I was taking these beautiful photographs, and I bring them up in Lightroom, and you zoom way in, and you think, man, that is awful. That is awful. And you're looking at a 24 megapixel image, but you're looking at a 10 by 10 pixel segment of it. Right?
Yeah,
so that when you are looking at things under a microscope, everything looks bad.
Yeah. I think this is the case though, where it really, the passband really is curved, and it's just that I might not have been aware of it.
My point is, you have a magnifying glass now. You can see it.
I do. I might have been blissfully unaware of this in the past. Back when we were drawing the filter curves with a signal generator and a scope and writing down the output. Pete's done this. Dean, you probably have done it too.
I have too.
Where you sit there and you plot it out, then you convert to log, and then you have the computer plot it, and wow, there it is. But I might have missed the curved passband. But now that I have an Arduino and a Nano VNA, boom, there it is, staring me in the face, taunting me. Anyway, this provoked a whole long line of me soul searching about this. But guess what? That was not the source of my crappy sounding receiver. The problem was the audio amplifier that I had put in there. I I had done an audio amplifier, and I just said, I think the problem is might be with the audio amplifier. So I pulled the audio amplifier that I had in there out, and I just sort of did some frequency response tests. I put an audio signal generator at the input, put a scope on the output with proper termination, and then I just manually swept across the audio passband, going from about 300 hertz up to about 3,000, 4,000 hertz. And sure enough, man, this thing was chopping off all the lows, and all the lows were just not making it through this audio amplifier. It was really accentuating the highs, and that's why it sounded tinny. So I pulled that audio amplifier out. I put the new board in. The board that I put in there, ironically, was the really simple one that we had from the Thomas Jefferson direct conversion receiver project. I had a few of these things floating around, and they were flat across the whole audio passband. I popped that thing in there, and bam, Bob was my uncle, as we say, and all the problems went away. So it was kind of it was an unnecessary diversion, but it was a good diversion because it made me think about the passband in the filters. Hey, I'm going a little bit long in the tooth here because of I'm going a little bit long here because of the because this has been a delayed a podcast. But speaking of new test gear, I did manage to blow up a tiny SA. I did. I put too much power in there. I didn't use the attenuator. Boom. But you can get a new one real quick, and I got a new one. I'll buy from Amazon from R&L Electronics. This is a really useful device. Anyway, the tiny SA permitted me to do kind of measurement and comparison on how much OIP was coming out, all kinds of stuff, and really very useful. Dean, one thing I would mention is that when you were going through the tale of woe on the amplifiers, one of the points that we discovered was you would get wildly different kind of responses from people depending on the class of amplifier that they were building. Somebody would tell you, oh, set the bias really, really low. And then you'd realize that he's building for class C. And then you'd get some guy who would say, set the bias really, really high.
Hey.
And you'd realize that he was envisioning the use of class A, and he was trying to keep it conducting at all times. And it was only in its intermediate area where you got kind of good responses. So that was a big part.
It's really interesting. And once you start measuring it, and this is again where the modern tools are really nice. So you put your tiny SA on there, and you're looking at the spectral products, and you can actually see what happens as you change the bias from low to high. You can obviously put it on the scope and see what happens to the actual waveform. But seeing that spectral view, that spectrum view and the spectrum analyzer is really cool. And the fact that we can do it for $100, I mean, there's a guy local here who's put a new Rigol spectrum analyzer on, and that sells new for $1,200. He's put it up for $675, and I'm like, I can't, even at half price, I can't see what it's going to get me that I can't get with this little device.
And not only that, when you blow it up, it's not like me. I blew up the tiny SA, and it's like
exactly
it's a cheap replacement, so it's worth it. And the tiny SA also handled a lot of other problems that I was struggling with when I was stuck in this kind of tale of woe loop. I was thinking for a long time that my carrier suppression was not good. But if you just take the output and put it on the tiny SA, you could take a look and see exactly how many dB of carrier you're putting out, and how does that compare to the peak envelope power when you start modulating. So it was, I think it's really, really good. And also it's a good.
We're back to don't look too close. Don't look too close, because you may not like what you see, and then you're going to fret over something that nobody can hear.
Yeah, I know, but sometimes I don't know. Sometimes more info is useful. Pete always says data. Pete always reminds us that data is very important. Data is very useful.
Good data is very important.
Hey, one other thing
Bill,
before. Yeah.
Can I interrupt you 1 second?
Sure.
You have caused me to think and think and think. 1015 rig. Is that a commercial dial that you have on there? Did you switch that over to a commercial dial? Is that like
I switched. This is an old dial. I'm glad you asked about
Eddystone?
that, because it's not an Eddystone. It's kind of I think it's a Lafayette. It's one of these cheap Lafayette. The border around it is cardboard, and it's got a little reduction drive in there. And you'll see I have a little screen over here where I've written down, I've sort of calibrated it for 15 meters. The reason I did put this back on there, and it's really kind of jury rigged onto there. But the reason I used this one and I selected this one to come back down to the Dominican Republic is that I acquired this dial more than 30 years ago from Hotel India 8 Papa.
There you go.
And I just thought it was fitting that it should return one day to the Dominican Republic, and that's where it is, and it's in use. Now, one thing I am noticing with this thing, with this dial, is that I can tune in SSB really, really well, but it's kind of finicky. I got to get it. So I might put another, like maybe a varactor or a smaller pot off to the side and just use that for fine tuning and not have to worry about, getting that dial just exactly right. This thing covers almost the entire 15-meter phone band as it is, but it might be nice to have a little fine tune circuit in there. I know this is something that Farhan had in the original BITXs. He had a little varactor that he would use for fine tuning. He would have a variable cap, I think. Well, no, I think he did it with the varactor all the way through, but you could work it out where you have a fine tuned varactor and a coarse tuned varactor.
You know who else did that?
Who?
Wes Hayward.
Yeah,
In his seminal 20-meter QRP single sideband transceiver, December 89, January 90 QST. You see a little fine tuned off to the side there. So you're traveling with the great path.
Oh man, it's very reassuring, Pete. Thanks. Hey, one thing I was going to mention and this was in the notes for the last podcast, and some of you guys may have noticed this. That before I left Northern Virginia, I was fooling around with a project, like a science project, sort of roughly related to ham radio, but it's something that I wanted to do since I was a kid. When I was a kid, my mom got me the book, The Amateur Scientist by C.L. Stong. And it was a compilation of articles that had appeared in the Amateur Scientist column in Scientific American. And holy cow, if you want to get an example of how things have changed, there was things in there: build a homemade X-ray machine, build a homemade atom splitter, everything else. I mean, it's amazing that we survived. But one of the things they had in there was a Wilson cloud chamber. And this was one of the first devices ever used to directly observe the effects of atomic particles. And the idea is that you build this little chamber and you introduce a temperature gradient from very cold at the bottom to room temperature at the top. You put a sponge with some isopropyl alcohol in there. The alcohol kind of evaporates, and when it hits the cold at the bottom, it forms a cloud. So you're actually making a little artificial alcohol cloud. And when an atomic particle flies through the cloud, it leaves a trail. Wow, that was pretty cool. I always wanted to do this as a kid, but it was always based on getting dry ice, which you couldn't get when I was a kid, when we were kids. But now Harris Teeter, they have a case out in the front where they'll sell you a chunk of dry ice. I think people are using it to cool down their beer or whatever. But I went there and bought a whole chunk of dry ice. I bought some Tupperware jars, and I set the whole thing up. And man, I got that thing going, and I was detecting atomic particles flying through me and the room and everything else. And I put videos up on the blog. So if you guys want to check it out, I checked off the box. I was joking with Dean. I was saying it was good that it was based on dry ice because that put a time limit on your experiment. Once the dry ice evaporated, you were kind of done. If you're going to do this, bring gloves to the Harris Teeter, because believe me, you do not want to grab that chunk of dry ice through the plastic bag in the freezer. You'll burn your hands. It's so cold. It's a lot colder than regular ice. But anyway,
I was wondering, Bill, about your middle name, Einstein Fermi. So now I know.
There we go. Yeah, I've now departed the 1.22 nanometer band, and work is concluded there. All right, guys, we're how long? We're at the 1 hour point here. Holy cow, time flies.
Wait a minute.
We forgot.
Shameless commerce.
The Shameless Commerce Division. Thank you, Pete. Thanks for reminding me. I would just like to thank all of our new Patreon sponsors. Several guys have signed up as Patreon sponsors. They're much appreciated. And I am trying to send some original videos, some extra videos that we have their way. So if you sign up as a Patreon sponsor, it's a really easy way to kind of support the podcast. and get some additional video that we will send out, available only to Patreons. Now, I don't want to deny it, the regular regular listeners, some of the important videos that we put out. So that stuff will always remain. But there occasionally we come across some extra video or or an early look at videos that are coming out. We put them up there. So please do that. And you know, we have a sponsor. I'm going to mention it. Carlos, the guy with the test leads. I didn't work it in here because I was confused because I was, you know, kind of busy with the move and everything else. But Carlos's test leads, I'm going to put a link up on the blog. He is our sponsor, and if you're going to buy some clip leads, buy them from Carlos. They're really good.
Use them
Pete's
all the
used them.
time.
I've used them, and we're going to get some for Dean too. So please make use of those. All right. And oh yeah, use the Amazon link on the right hand side. Anytime you're going to buy something from Bezos, or as Pete puts it, what's her name's boyfriend?
Lauren Sanchez.
Amazon.
Amazon.
Start there. Just start. If you just click on the link on the upper right hand side of the SolderSmoke page, boom, we get a little chunk of change from Bezos. So that's very, very welcome. Thanks for everybody who does that. But listen, I got to go to the mailbag now. And this is a lot of this mailbag is some of it is new, some of it's a little bit old. But first, thanks to Bob Crane, W8SX, for going out and doing the interviews at 4 days in May. I will get them out. The problem is Bob sent them to me by a CD, which is great, but it arrived just as I was getting ready to leave to come down here, and it's up on my desk in Virginia, which we will get back to in a month or so, and I'll then start putting them out on the blog. But thanks for doing that, Bob. Really appreciate you being our correspondent in Dayton or Xenia or wherever they're doing FDIM these days. So thanks for getting that out. Hey, Pete mentioned Wes. Wes has a new TIA amp on his website. I got a package from our friend Todd out in Portland, and I alerted him to this. It's a TIA amp with variable gain, completely variable, set by a pot. He's got a pot in the circuit. And if you check out w7zoi.net, you'll see the circuit there. So that's really, really good stuff. Thanks for doing that, sharing that with us, Wes. Joff, N6GWB, did a rad receiver, and we have the link on the page. Check it out. He's anytime there's a homebrew receiver, we're very interested. Thank you for sending that, Joff. Dave K1KA sent me a bag of parts with an entire ensemble RTX SDR rig in there, and I am going to find an appropriate home for that as soon as I get back to Virginia. I'm looking at you, Dean. Somebody we know might be looking to build an RTX SDR ensemble receiver, one of the earlier SDR rigs. Pete, let me know if you're interested in this also, but I know your time is so limited. Oh, you got two. I do. Pete's got two of everything. All right. I told you that we got some great email from Chuck Adams. He's got a new call sign, Alpha Alpha 7 Fox Oscar. And he provided great information on my MX rig, including the meaning of MXM 1990. Thanks. It was great to hear from Chuck, and he's a real homebrew hero. His workbench manual is just a classic of ham radio literature. So many great videos, so many great things he's put out over the years. Thank you for all that you've done for homebrew radio, Chuck. Gerardo, HI8P. Now, I mentioned the dial that I got from HI8P. But that was Pericles, and he was an old-time radio amateur. He unfortunately passed away while I was here. I went to Pericles' funeral, but HI8P, Gerardo, is the new holder of the call, and he is collecting info on the original HI8P, my friend Pericles, who's now a silent key. So I sent them all the information I had about HI8P, including stories of helping me fix my HT37, making the first satellite contact. I said that Pericles, I took Elisa over to his house one time, and she was just horrified because the house had so many antennas up on top. It looked like, I mean, the house sort of looked like it had been attacked by kind of War of the Worlds Martians. You know, they had put their kind of web over the house. And I think Elisa was worried that I might try something similar. But not that bad. But anyway, HIP, Gerardo's collecting that. Good to hear from you, Gerardo. Alvin, N5VZH. he also picked up a Silktronics CB VFO. I picked up one of these things at Winterfest, and he's asking what he should do with it. I said, man, there's so many things you could do with this. It's a very solid VFO with some good capacitor drives in there. So hold on to that thing, Alvin. Do something useful. Do something good with it. I'm going to do something good with mine. Jorgen, SM4 WWG, is listening to the podcast from Sweden and making PCBs. Fine business, Jorgen. Thanks for the note. Mike, WN2A, he wondered about the opposite sideband rejection of the MXM transceiver, and I tested it for him. Not really great. Not really great. So I mean, you could listen if you got it set up so you're gonna for upper sideband. You could also listen to lower sideband. It's kind of broad for the MXM. A member of the Vienna Wireless Radio Club, a guy that we talk to all the time, a great fella, George WB5OYP. He loaned me a book from a guy named Elmer Butcher. Elmer Butcher. Now, I was commenting at one of the VWS meetings that ham radio operators seem to have these kinds of names. There's a lot of Elmers, a lot of Elrods, names that you don't hear too often anymore, but there's a lot of old ham radio operators. There's a lot of Pete's. Pete's is not in the same category, but there's an awful lot of Pete ham radio operators. But Elmer Butcher. Now the question is, was this the original Elmer? The Elmer that we all use the term be an Elmer, and there's several different stories about it. One of the stories is that Elmer Butcher, which is the real guy's real name, who wrote these books about very early wireless. I mean, I'm talking about Ford spark gap transmitter kind of thing. He might have been the original Elmer. Now there are other stories. Dave Newkirk, the guy who wrote the How's DX column, Rod Newkirk, he claims to be I think some people think he originated the term, but there's a possibility that it's older, that it might go back to the actual Elmer Butcher, and that might be the source of Elmer. What do you think, Pete?
Don't know.
We'll find out. So I got a link up there. West W7ZOI, Farhan VU2ESE. Thanks for the help on the filter issue. Also, thanks to Alan W2AEW and to G3UUR. We've been in contact with G3UUR himself. It's great. I asked him questions about the filters and the methods that he gave us to measure the crystal filters. And he said, "Oh my God!" He said, "I wrote those articles 30 years ago." And
he was delighted to hear from. In fact, I couldn't find one of his articles that is referenced in all of the articles about him, and so I asked him for it. He couldn't find it, so he finally pulled it out and sent it to me. So I have now a full suite of G3UUR articles on those filters.
I think this just demonstrates another thing that I've been saying for a long time, and that is the value of posting, the values of putting things out and sharing things, because once it goes onto the internet, it's pretty much forever. And 30 years after you write something, somebody might be scratching their head wondering, why is my passband curved? Why? And boom, the next thing you know, you're looking at the G3UUR
on the other hand,
1992.
On the other hand, and people recognize this 5 years after you post something, somebody will write to you and say, I tried to load your sketch into the Arduino and it doesn't work.
Your design stinks. Well, we just got to ignore those kinds of comments. Josh, G3MOT, sent me a nice message in support of our struggle against the authorities in San Francisco who were persecuting and prosecuting me. Thank you for that kind message of support. I don't think Josh fell for it, but he just sent us a message of support. He is going portable to Vancouver Island in August. He will be Victor Echo 7 stroke G3MOT in just a few weeks. So listen up for him. Our friend Paul down there in Australia sent me a message of Antipodean solidarity when it looked like the San Francisco authorities were coming after me. Thank you for the Antipodean solidarity there, Paul. Roger, Papa Alpha 1 Zulu, always provides great input and help. Thanks for all the nice messages, Roger. Tony, G4WIF, another great friend out there this time in the UK. He reminded me of G3 ROOs of Ian's Parasets. And I have something on the blog. We've had some recent Paraset news because Mike WU2D just put out a really nice video about whether he should part out his Heathkit SG6 SIGGEN and use the parts for paraset construction. I don't know. Let's see.
Universally, everybody responding to his blog said, "Part that sucker out."
I didn't see it. I might have been the only one who said no. I said it could be turned into a useful rig. I turned mine. I solid stated mine. I followed Farhan's advice. Farhan built a signal generator using straws from McDonald's. He went to McDonald's in Hyderabad with his kids, came back with some straws, and used the straws as the cores for some coils that went into the SIGGEN. So I followed Farhan's lead there. Speaking of this kind of stuff, Pavel CO7WT writes in from Cuba with information about the Hagway DSB rig that a lot of them were building at the time. And he talks about how they stabilized the VFO. Pete, brace yourself here. I mean, brace yourself. This is really kind of some scary stuff. But Pavel talks about how they after they built the board for the VFO, they went through a series of freezing and heating the board. They would stick it in a freezer and get the temperature really low. Then they would take it out and put it in the Cuban sun, which, believe me, will get it really hot. And then they would go through several cycles of this. And apparently the belief is that this added to kind of the stability of the VFO. I checked on the internet. Even Farhan was talking about doing similar stuff. So there does seem to be some kind of at least evidentiary basis for doing this kind of stuff, as crazy as it sounds.
Even Wes used to boil the toroids.
Yeah, boiling the toroids, we hear about that more often. Taking the whole board and sticking it in the freezer and taking it out and putting it in the Cuban sun. I mean, it's interesting.
Stress relieving.
Stress relieving. Yeah, that's it. All right. Grayson, KJ7UM, our buddy, the author of Homebrew Design for the Radio Amateur, Hollow State Design for the Radio Amateur. He sent me the latest issue of Electric Radio with his own Collins 51S1 story. There's some more really good, really true radio restoration and radio rejuvenation. Thanks for sharing that, Grayson. I mentioned Allison.
Before you move from that, he's built a Michigan Mighty Mite with a 6C4 tube.
I can't wait to see it.
Yeah, he has some pictures. Yeah.
Oh man, I gotta check it out.
He asked if we had any crystals. I sent him a couple crystals, and he sent me pictures. He says it's working.
All right, good. Has he contacted anybody with it yet?
I don't know, but he's got it working. He said, and actually he looked at it on a spectrum analyzer, and he said it looks really good.
He should use the reverse beacon network and get that thing going and see if he can see himself. You got it, Grayson. Reverse beacon network is your friend. It provides an incentive for calling CQ on CW. There you go. Allison KB1GMX I mentioned she's been very helpful and was commiserating on higher frequency crystal filters. Thank you, Allison. And finally, we got a message from another VWS member, I think, West W4JYK. And Wes notes that our law firm, Dewey, Cheatham and Howe, that they are based in San Francisco, and they could be of help with our sticky sticker problem. So thank you for that, Wes. And anyway, that's that. Listen, guys, we've been going on for an hour and 15 minutes here from SolderSmoke Shack South. Pete, you got anything else? Dean, anything else for the group?
No, we are good.
All right. So hopefully we're going to get this thing out here in the next few hours. But thanks to everybody for your patience. Sorry for the delay. Hopefully we'll be doing this more frequently. Pete, thanks for getting up so early in California. Dean, on a hot day in Virginia. And it's a real pleasure to talk to all of you from SolderSmoke Shack South. So 7-3 from the Dominican Republic.
Before you sign, Bill, one of the things that'd be kind of cool is open that window and take a picture and put that up on your blog so people can see what you're forced to look at every day.
I'm going to do it. If the problem is, if I opened it up right now, the morning sun would come pouring in. You'd see nothing else. But that's a real good idea. I'm going to go out. And take some pictures so you guys can see what it's pretty spectacular. Pete checked out the circuit yesterday, and I took the Chromebook and walked outside, so he got a view. So I'll do that. Thanks for Pete. Thanks.
Yeah, even.
Okay, so 7-3 from the Dominican Republic.
7-3 to the left coast.
7-3 from Great Falls.
Thanks, guys. 7-3.
See ya.